This is a short video to just get everybody on the same page on how to track your position using APRS. APRS is automatic position reporting system or automatic packet reporting system, depending on who you ask. It's a system that has been around since the 80s. So one of the advantages of APRS is that there's a very widespread infrastructure all over the US and all over the world. And to put it simply, the way that APRS works is by radio stations exchanging radio packets between them with some small amount of information, typically the position, but could also be position, speed, and direction. And that means that these stations know where everybody is. If you have internet connection, you can also send that information through the internet. So both the internet and the radio components work together, and you get to see a map of where all the stations are. And even better, you can exchange messages. So I can send a message. If I'm on the West Coast, I can send a message to the closest APRS station, and that station, if it has an internet connection, will route it through the internet to another station in Georgia, to whoever I'm trying to connect, and send them that message. So it's that smart. It's very powerful. You can use it to track a vehicle over time. You can use it to send messages. You can use it to send text messages to somebody that does not have a radio license. So I use that when I don't have cell phone coverage. I send a text message to my family saying all is okay using APRS. And you can even do fun things like bouncing APRS signals off the space station. So the space station has a radio that works as an APRS digital repeater or digipeater. So digipeaters are specific APRS stations that when they hear a message, they see if it still needs to be repeated, and if it still needs to be repeated, they will send it away again. They will retransmit it. So that helps the information propagate. So what we're gonna do in this video is we're gonna do two very simple things to give everybody an introduction to how to get started with APRS. This is by no means a tutorial. I suggest that you just go to YouTube and Google, and you will find something specific for your setup. But this is at least the lowest level just to get us all started. Okay, now we're going to look at how to do APRS using an iOS application. The application that I use is aprs.fi. I'm going to click on it. It's right here in the bottom left. I'm going to click on it, and this is the app that I use. What you see here is basically, if you click the location position, that's my current position at Georgia Tech in Midtown Atlanta. And you see that there's a little icon on top of my position. That's a truck, and it says KK4ODA-9. That's the last beacon that I sent. That's my APRS position. So APRS allows you to plot your own position and look at other stations and see how far they are and where they are. You have a number of icons here in the bottom. The first one allows you to see how long of a time range you want to look at. Let's say 1 hour. So all the beacons that have shown up in the last hour. The next one is a filter. I want to say, show me only packets that come either from the network, from the internet, or from the TNC, which is the device that connects the phone to the radio. In this case, I don't have a radio connected, so it's only going to be from the network. And then you can choose the stations, type of stations that you want to see. For example, I want to see only stations that are moving at a greater than 1 mile per hour. Okay, I'm going to see all of that, or I can look at all the stations. And that's just a filter. And it has, a few other nice features. I can make the fonts larger if you don't have good eyesight like I do. You need glasses, or you can make it smaller. You can change the type of map. This is a satellite overlay. You can remove all the all the streets, or you can just use a plain map. Okay, so this is really the why APRS is useful, because you can zoom in and you can see, for example, here, this is Greg's station, WC4Y-10. You see a WD5EMA-10 connected to Stone Mountain. That's our that's a WinLink gateway. Okay, so that's what it's showing. And for example, here you see there's a truck, KF4TJY-10, and if they were moving, you would see a track. You would see where they've been going and so on. Actually, here you see NF4L, that's Nathan, and you see a track that goes around Peachtree Airport, and that's what we saw for what he was doing for the last hour. So it gives you a lot of information that's useful for situational awareness. One of the most important windows is the middle one that says beacon. So if you press on the beacon window here, you can beacon your position via APRS.is. That's the internet. Or you can also beacon via your TNC. In this case, it's off because I don't have a TNC connected. You see I'm using a station that is KK4ODA-9, but if you touch on that, you can change to other names for your station. Typically, -9 is used for mobile stations, trucks or cars. -7 is used for individuals that are walking. -1 is used for fixed stations, and so on. You can configure the transmit interval, the minimum and the maximum. I chose those two based on how well I want my path to be plotted. And that works well if I'm driving, but if I am not driving, if I'm stationary, I will probably not transmit this often. And you can say beacon now. You see down here, beacon now. I can push on that and it will send a new beacon. You see the time since transmit was 5 seconds. Okay. The last thing I want to show you is the messages window. The messages windows, this is where you can message different stations. You see here, W4TGA-9, that's Barry's truck. I sent him a message. This is like a year ago saying Merry Christmas, but he didn't get it. So how do I know? Because his station did not acknowledge the message. We can try sending him another one, but I don't know if he's gonna be around. It says delivering 1 of 6, so it's gonna try 6 times. If his station is on and listening, it will typically send an acknowledgement back saying, I got your message. And that's how you know if it was delivered, but sometimes it's not delivered. Maybe they're out of coverage. But one of the nice things about APRS is that you can use it to message people that are far away if there's no cell phone coverage. This one is interesting. It's called SMS, and you can use it to send text messages. So see here, I was messaging my wife when I was out of cell phone coverage. She is used to me messaging weird ways, so you can try that. That's called SMS. That's another APRS service. And finally, this is the settings window here. And I do have a subscription, but it's very inexpensive. It's like $5 a year. That gives you some extra features, and you can explore all of these settings. I'm not gonna go into all of these settings. Okay, I wanna show you now one of the ways of how you can do APRS with a Windows laptop. I have several APRS applications installed. I have one here called APRS IS32. I have another one called Pinpoint APRS, and I have another one called YAAC, YAAC. Of these three, the easiest to learn is Pinpoint APRS. The other ones they have many more features, but are a little bit more complex. So let me just show you a little bit about Pinpoint APRS. I'm gonna open it real quick. And this is by far the one that is the best in terms of the interface, I would say. So it basically starts with a map, and if you go to Tools, Options, this is where you can set all the different options. So you start with setting up your call sign, and the path that I'm using, the default path
You can put a comment if you want every time your packet is transmitted or not, and then you can choose the icon that you want for your station. I'm just choosing a laptop. This is the beaconing settings. It says enable APRS beaconing, beacon at least every 15 minutes, beacon a minimum every 3 miles if you're driving, or when your heading changes more than 35 degrees. Those are default settings, and you can beacon your course and speed or not. So if you're gonna, then you don't want to be broadcasting your speed. Okay, so that is the general settings. Then the next window is the TNC settings. This is what type of connection to your radio you're going to use. The simplest one is to use a network KISS TNC that connects to another piece of software, which is a software TNC. I use one called Sound Modem, but there's many options. You have some radios that have built-in TNCs. You can use a serial KISS mode, or you can use any other. So there's many ways of doing this. It's beyond the scope of what we're doing in this video, but if you have a radio that you can connect to APRS using, for example, a digirig, this is where you would set that up, and you would choose the TNC settings. You would choose the COM port, the speed of the COM port to match your digirig. But if you're using a network modem, then you have to say, hey, this is the address of the software modem. It's the local address, local IP address, and this is the port that the software modem is listening to. Typically, you do need a GPS. Unless you're stationary, you need a GPS, so you would use a GPS plugged into a USB port, and you would here in this window you would say connect GPS when pinpoint starts, or you can connect it manually. You can say this is the display for your display format for your position. I typically like the decimal setting, but all it does is just reads the position. I will plot it on the map. The next window is the map. These are all the options for the map. I'm not going to read them for you. It will download the map while you have an internet connection. If you don't have an internet connection and you never looked at that area, you may not see the map because it's not been downloaded. The next tab is the APRS.is. So that is the connection to the internet. So you will need to generate a passcode. That is, if you Google it, you're going to see how to generate it. All you need is your call sign to get this passcode, and then it will get all the APRS packets from the traffic on the internet. So if you click OK, you go here on the right, you say it says APRS.is reports. And right now the APRS IS is disconnected, so I'm going to connect it. I'm gonna say connect APRS.is. Now it's connected, and you're gonna see my APRS reports are gonna start trickling in. You see how 2, and it's gonna get you reports within a certain area. So if you go to the options, it's gonna tell you, how wide of a net you want to cast. Okay, so I don't remember where you set that up, but there's a mileage. Yeah, here we go. Receive range 25-mile radius from my position. You can change that. If you open it too much, you're gonna get too many packets. You may run out of memory. But you see, I'm zooming out, and I'm starting to see different stations. So you see this station here. It says this is my position. That's not correct, but I don't have a GPS connected. Okay, so if you keep zooming out, you're gonna start seeing slowly more packets coming in. Okay, so this green star, that is a digipeater, WB4 GMB. That's a digipeater. Okay, so this is basically how it works. And if you want to send a message to somebody, you can send a message using F6. You just type in the call sign and you type in your message here and you click send. Because you're connected to the internet, it's typically going to send it through the internet, but if you have a TNC connected, you can also send it via radio. So if the internet is down, you can use the radio. Okay, this is like the fastest introduction to pinpoint APRS that you're going to get, but I encourage you to experiment with it. All you need is a laptop, a radio, a 2-meter radio, and then an interface between the radio and the computer, typically a digiRig.